So in this example, we're given what they call a square root function. It's a function which is defined using a square root, a radical with an index of 2. And the question asks us to find the domain of this function and to write the answer using interval notation. So domain is something that we have to explain. This is a new concept, and the reason it's new to our course is because it's a property that functions have. It's not really a property that algebra belongs to algebra, really. It's a property that belongs to the study of functions. So first we have to kind of get an idea of what domain is, what it means. And then once we figure out what that is, we'll know how to proceed. So the strategy here is to remember what domain means. The domain of a function tells us which x values, x is representing the input to our functions here, which x values are legal to put into this expression. In other words, which values of x can I put into this expression, square root of negative x plus 9, and get out an answer that makes sense, an answer which is a real number. So here's the key. The key to domain questions when they involve radicals, especially when they involve square roots, is that we may only take a square root and get a real answer if the quantity underneath that square root is non-negative. So in other words, the arguments of square roots, arguments meaning the inputs, the stuff that's underneath the square root, has to be greater than or equal to 0. So our strategy for this problem is going to be to first, because we see a square root in this function, to look for the expression which lives underneath that square root sign. And because we know that we may only take a square root of a non-negative quantity and get a real answer, that means we need to just insist that the expression underneath that square root be greater than or equal to 0. That gives us an inequality that involves x. And if we solve that resulting inequality, we get an answer, an expression which tells us which x values are legal to put into this expression and give us a real answer. So if we solve that resulting inequality, we're going to get something like x less than or equal to 6 or something like that. And then because this answer asks us to also express that solution using interval notation, this is something you're going to do in pre-calculus over and over again as well. We're going to finish up by sketching that inequality on a number line and using that sketch to determine interval notation for our answer. So first, here's some motivation. Here's the main idea behind what we're about to do. If I'm taking the square root of a quantity, what I'm looking for is a number which multiplies by itself to give me the original quantity. But square roots of negative numbers are not real. And to explain why, let's just look at a simple example. If I want to know what the square root of 25 is, for example, I'm looking for a number which, when multiplied by itself, gives me an answer of 25. And clearly that answer is 5 because, well, 5 multiplied by itself, or 5 squared, is 5 times 5, which is 25. So that works out. The square root of 25 is 5 because 5 squared is equal to 25. But on the other hand, if I decided to put a negative sign in front of the 25 underneath the radical and ask what is the square root of negative 25, I might be tempted to say, well, is it equal to 5 again? And the answer to that is no, because 5 squared is not equal to negative 25. 5 times 5 is positive 25. Well, okay, you say, well, why don't we just say the square root of 25 is negative 5? Well, let's check and see if that works out. What's negative 5 squared? Negative 5 squared is negative 5 times negative 5. And when those negatives multiply, we end up with positive 25 again. So this is an illustration of the common sign property of multiplication of real numbers, which says that when I multiply any two numbers of the same sign by one another, I'm going to get a non-negative answer. In other words, it's impossible to multiply two real numbers and get an answer which is negative if those real numbers both originally had the same sign. And since we're squaring numbers here, we're multiplying a number by itself. So of course those two are going to have the same sign. So all of that is a long-winded way of convincing you that the square root of negative 25, for example, is not a real number. There's no way for us to multiply any real number by itself and come out with a negative answer. After all, positive times positive is positive. Negative times negative is also positive. And 0 times 0, of course, is 0, which is not negative. So we cannot multiply a real number by itself and get a negative product. Therefore, the square root of any negative number is not real. And that's the observation that powers this entire problem. Let's use the examples that we just looked at and take this function, f of x equals the square root of minus x plus 9, and look at what happens if I evaluate this function, for example, when x is equal to negative 16. So I plug a negative 16 to the input of the function f and evaluate the result. Well, that just replaces the x in that expression with the number negative 16. And f of negative 16 is therefore minus negative 16 plus 9. Minus negative 16 is positive 16. Add that to 9, and I get 25, and the square root of 25 is 5. So what does that mean? Because we were able to plug negative 16 into this function and get an answer which is a real number, that means that negative 16 is a part of the domain of this function. Negative 16 belongs to the domain of f. So whatever our final answer to this question is, our answer had better include the number negative 16. Well, okay, but then what could possibly go wrong? What happens if I try plugging different numbers into this function? Let's say I try to plug in the number x equals, I don't know, 34. If I try to plug the real number 34 into this function, then f of 34 is going to be minus 34 plus 9 underneath the square root. But negative 34 plus 9 is negative 25. And hopefully you're already convinced that the square root of negative 25 is not a real number. In other words, if I try to put the number 34 as an input to the function f, the output that I get is not real. It's not a real number. And since our course only deals with real numbers, that's where our story stops. In other words, 34 is not a legal input, not a valid input to the function f of x. Therefore, 34 does not belong to the domain of f. So whatever our answer to this problem is, it had better not include 34, but it does include negative 16. We, of course, won't be satisfied until we can answer the question, what are all of the things that must be included in our answer? What are all of the values of x which are legal to put into this function? So to answer that, we'll go back to our step-by-step strategy. First thing we want to do is look for expressions that live underneath the square root. This same tactic, by the way, works for roots of any even index, so 4th roots, 6th roots, 82nd roots, and so forth. So the expression underneath that radical must be greater than or equal to 0, and that expression is minus x plus 9. So we can solve this problem merely by insisting that minus x plus 9, the expression under the radical, be greater than or equal to 0. And this is a rather simple inequality that we can solve just by getting the x by itself. Reversing the order of operations, we can do that by first adding 9 to both sides, subtracting 9 from both sides, to give me minus x is greater than or equal to minus 9. And then to get the x by itself, I just need to divide both sides by negative 1. Except that I have an inequality, and whenever I divide an inequality on both sides by a negative number, I also have to remember to flip the sign, flip the sense of that inequality as well. So when my x is by itself, and I get a 9 on the other side of the inequality symbol that I get flips around to be less than or equal to. So after all that work, what we figure out is that in order to make the expression underneath the radical greater than or equal to 0, it is sufficient to make x less than or equal to 9. So the domain of this function consists of all x values less than or equal to 9. And just as a quick consistency check, negative 16, which is supposed to belong to the domain of f, according to what we said before, works in this inequality because it's less than or equal to 9. But 34, which we earlier said was not a part of the answer, cannot be a part of the answer, does not work in this answer because 34 is not less than or equal to 9. So that passes our little gut check from the work that we did earlier. So one way of expressing our answer might be of saying that the domain of this function is the set of all x's which are less than or equal to 9. However, the problem asks us to express this in interval notation. And the way I like to do that is always to take an intermediate step and sketch this inequality on the number line. So to sketch this inequality on the number line, we need to put its upper limit up there at 9. Since x's are less than or equal to 9 in our set here, that means we're going to shade everything to the left. Because our inequality is a non-strict inequality, it's less than or equal to 9. That means that the number 9 itself is a part of our solution. So we'll put a big a filled-in circle there at the right-hand endpoint of our solution. And then what is the left-hand endpoint of our solution? Well, we don't have one. It goes all the way to negative infinity on the left-hand side. So interval notation for our solution is going to have negative infinity and 9 as the left and the right extremes, respectively. Then we just need to put in notation that tells us whether we're going to include those numbers or not. Well, 9 we are going to include in our solution because, again, x being less than or equal to 9 allows for the possibility that x is 9. So 9 is a part of our solution in this problem. And as a check, if we were to plug 9 into this function, we would get the square root of minus 9 plus 9, which is the square root of 0, which is 0, and that's a real number. So 9 does belong to the domain, which is why we need that square bracket in our final answer. On the other hand, the negative infinity at the left-hand extreme of our interval is not a number at all, and so we cannot include it in our answer. So here we found the domain of this square root function by asking ourselves what values of x can we put into this expression to give us a real number coming out the right-hand side. And we figured that out by insisting that the expression underneath the square root be non-negative, greater than or equal to 0. And simply by setting that expression, minus x plus 9, greater than or equal to 0, and solving for x, getting x less than or equal to 9, that gives us an expression of our answer. We then just had to convert that answer into interval notation. To do that, we sketched it on the number line, found out that the left and the right extremes of this interval are negative infinity and 9 respectively, and then we convinced ourselves that we need to exclude minus infinity from our solution because it's not a number, so it's never part of our domain, but to include the number 9 in our solution because x being less than or equal to 9 allows for the possibility that x is 9 itself.